Good night. This should be Professor Dr. Dolphy Gilpin. And as promised, we would have done a little short excerpt on the element 103, representing Lawerencium. We'll also give the new modern nomenclature for it. (103) that look like nil tri ium. Nil tri ium. That would be the modern nomenclature for it. Element 103. Let's see. Lawerencium 103, atomic number, and an atomic weight of 266. It's synthetically produced. This doesn't occur in nature naturally, synthesized in the laboratory by one Ernest something. I'll soon let you know his name. But here's the atomic number 103, 266. It's artificially produced or synthetically. Let's look at it some more. No notes here. So we are in Lawerencium. Atomic number 103 and atomic weight of 266. I do believe that it has some isotopes there too, but all of them they have short half-lives. They doesn't remain with us in the environment for long. Let's see. It's uranium. Very short notes on Lawerencium here. Here we are, Lawerencium. Okay, the shell configuration is 2, 8, 18, 32, 32, 8 and 3. So that is all the shells are designed with the electron layout. 2 in the first shell, 8, second shell, 18, third shell, 32, then another 32, then 8 and 3. The electronics configuration is Rn, like noble gas, radon, 5F14, 6D1, 7S2. And that's for one of the isotope, the 262 isotope. It would be Rn, 5F14, 6D1, 7S2. But we'll mention a couple more of the isotopes there. This one is a 7P1 down here. So we have like its name was discovered by Ernest Lawrence, the inventor of the cyclotron, a device that is used to discover many artificial radioisotopes or radioactive elements. Yeah, Ernest Lawrence, he invented the cyclotron, which is a device or a machine that or instrument that is used to discover many artificial radioactive elements or radioisotopes. So we have like that one is for 262, I believe. You have 266 Lawerencium, you have 262 Lawerencium, but what you have is the symbol now, the modern symbol nomenclature would be UNT, and the name would be unyl trium. Unyl trium, yeah, element 103. Melting point of 2,961 degrees Fahrenheit, which is the equivalent of 1,627 degrees centigrade. The boiling point is unknown, and it does not occur naturally. Lawerencium. And we have the atomic mass or weight ranging from 254 to 266. Yeah, the Lawerencium, so the isotopes or the average weights of the isotopes or the isotopic weights would give us about 262. But it's ranging from 254 to 266. So this one you're seeing Lawerencium 266 atomic weight. And this one is saying 262. So therefore they will have different electronics configuration with a stable radon as the noble or inert gas. So yeah, the atomic mass ranging from 254 to 266, and the atomic number, which is stable at 103. Oxidation state of +3. And common isotope is the Lawerencium 260, the Lawerencium 262, and the Lawerencium 266. It's purely used in research. It has no biological proven role as yet. It's just purely used for research purposes. It is produced by bombarding californium with boron. So in the laboratory, it was produced by bombarding californium. Californium, you know, has an atomic number of 98 and atomic mass. Let me see if I could see that here. 98 and CF. It's not immediately visible, tangible. So let us see. Californium bombarding californium with boron. And Lawerencium it is said to have many or rare commercial and industrial application. Lawerencium is highly radioactive, and the most stable isotope is Lawerencium 262. So that's the one that is put upon the periodic table, or the partial periodic table shown there, the Lawerencium 262, and which has a half-life of about 4 hours. So the most stable isotope, LR262, has a half-life of about 4 hours, and the property is that the faster an element decays, the more energy it emits in the form of radiation. So with such a short half-life, Lawerencium emits a great amount of energy. Lawerencium is going to react with oxygen and air. It will also react with hot water and acids. So Lawerencium will react with hot water, acid, oxygen, and air. It contains a mix of nitrogen, oxygen, and other rare gases and other gases. That's a bit of hydrogen there too, but the Lawerencium will react mostly with the oxygen and the nitrogen in the air, with hot water and with acid. Lawerencium is in the D block. It's also sometimes referred to as an F block element. And was discovered at the University of California, Berkeley, by one Eric Lawrence. And so that name. So we come on to the other name, which is the IUPAC name of one would be unyl trium. It has to be ending IUM. So unyl trium. That would be the IUPAC name for it there as well. And we'll come to name a lot of elements after 100 by the IUPAC system of nomenclature for it. And 104 would be unyl quadium. So unyl quadium would be for 104. 105 would be unyl pentium, and so on. But let's take a break and we'll return to some more elements in the periodic table.